Hey there, ECSers. Welcome to our new online class. We're going to continue on with data analysis, and we are going to be taking our data and sorting through it and creating subsets to see if we can pull any information out of those subsets. So you want to click the LA bike data file here. It's going to bring up a spreadsheet that looks like this. And let's start by talking about the data that's inside of here. Basically, a biking group wanted to argue that there should be more bike lanes, bike routes, bike paths in LA. So what they did is they put a bunch of volunteers at these different intersections, first in Alameda, 7th and Figueroa, and they had them write down the type of route that it was, and then they counted how many bikes passed through during a certain time period and how many pedestrians passed through. Then they were going to use that information to make arguments, like I said, to add more bike paths where necessary. So we've got our headings going across here. Longitude and latitude is basically giving you the location of this street. So we could use GPS to plot these different locations. The type is the type of bike path. So if there's none, it says none, but they have bike routes, bike paths, and there's a bike lane as well. So we're going to be sorting through this data to see what it can tell us. This data set is rather small. We only have 39 entries in here. So what we're about to do, you could actually do by hand, but I wanted to show you how to do it with a simpler data set before we got into larger ones that it would be pretty crazy to try to do it by hand. You'd be there forever doing that information. So let's go ahead and dive in and see what we're going to be doing today. So the first thing that we're going to do is we're going to create a frequency chart. How many bike paths had none, how many were bike routes, so on and so forth. So we're going to use what's called a pivot table for this. Pivot tables are a way to analyze your data, pull information out of them, and then we can use those tables to then to create charts and graphs to visually display that information. So we're working with data. So let's go up here to data, and then we're going to go down to pivot table. So click on pivot table. Now it's asking us, what is the data range? So I'm going to move this out of the way, and then I'm just going to highlight, right? It's from the very top. We want to include the heading names, and then all the way down till your last line of data. And so now I've got my range. Wait, it didn't take. Oh, I didn't have, sorry. I needed to click on data range first. Now I can come in here and highlight and show it. So it says LA bike data A1 to F39 with a colon in between. All right, that is our data range. Now it's saying, where does he want to create the pivot table? Do you want to put it into a new worksheet? So we would create another worksheet down here, but I'm going to say existing worksheet. Then it's saying, what cell do you want to put it into? Let's just click on H2 right here and click OK. Now that we've given it all the inputs, click OK to create the table. So it's going to drop in rows, values, and columns here. Now, you may have noticed over here to the side, we've got the pivot table editor. So it gives you some suggestions for tables that it thinks you should create, but we're going to create our own. So I'm going to come down here to rows. I'm going to click add, and we want to know what the different types are. So I'm going to click on type, and it adds in bike path, bike lane, bike path, bike route, and none. So for the next thing I want to know is the value. How many of each one of these? Remember, it's a frequency chart. So how many of these were there? So I'm going to come down to values, and I'm going to put in type. And the default is generally to some, right? I don't know what, not sure what yours is going to be, but generally default is to some. So these are all the different types of mathematical calculations we can use. And we're going to use this top one, count A. So I click on that. It's going to tell us that there's 5 bike lanes, there are 6 bike paths, 7 bike routes, and there are 20 that don't have anything at all. So that's pretty telling, right? That the majority of streets don't have anything on them at all. I think what would be even more helpful is if we had a percentages here to make this even easier to understand. So I'm just going to throw in a quick little formula here. When you're dealing with formulas, you have to start off with an equal sign. Then I'm going to click on I5 because this is how many bike lanes there were, and then our grand total was 38. So basically we're doing a division problem, 5 divided by 38. But I'm going to do this so that the spreadsheet can do some of the work for us. So I'm going to do the equal sign, and I'm going to click on this cell. Then I'm going to do the division, right, the backslash, and then rather than, I'm going to select the cell. Notice it didn't put in 38, it put in I7. So I'm going to make this I7 a absolute address, meaning it's not going to change when I copy the formula. It's going to change the numerator, the I3 will go to I4, I5, I6, but the I7 won't change because we want that to be our denominator for all 3 of these. So in order to make that happen, I am going to click in front of the I, and I'm going to put a dollar symbol. Then I'm going to go on the other side of the I in front of the 7, and I'm going to put in another dollar symbol. I hit enter. As you can see, it gives me 13%. So the reason I put in those dollar signs is so that I can copy this formula down now. The easiest way to copy it, this little blue box right here, if you just click and drag it, let go, it's going to throw all of those percents in for you. Next, I want to turn this into a percentage, and I'll go with no decimal points. So if we add all of this up, it should hopefully get us to 100%. There could be some rounding issues, but we can see that over 50% don't have any bike routes, paths, lanes, anything at all. So I think that's something that you could use to argue that there's not enough bike lanes currently in LA County. All right, let's see what else we can do here. So now we're going to sort the data. I want to know which intersections have the highest bike counts and which ones have the highest pedestrian counts. So make sure that you're inside of your data set here. We're going to go up to data, and we are going to sort. All right, ladies and gents, so now we are going to sort through our data. We're going to use filters to sort through the data, so I'm just going to click inside my data set here. I'm going to come up to data and then create a filter. When you click on that, you see you get these little drop downs here. So if I wanted to sort by bike count, now it just says A to Z or Z to A, but 1 to whatever to 1. So I'm going to go Z to A, and we can see that Hoover and McClintock was the busiest intersection for bikes at 977 people crossing during that time. So the next thing I wanted to look at was the pedestrian crossing. So now I'll click on this and I'll sort it Z to A, and I can see that Westwood and Le Conte have the highest pedestrian count at 3,806, while the bike count was relatively small at 220. So filtering your data, it's really easy. I could do it by type if I wanted to, right? And it's going to adjust everything. So there you go, sorting your data. So next we're going to be looking at creating a subset of intersections where the bike traffic exceeded the pedestrian traffic, which is what this group was trying to demonstrate. So we're going to, again, be using, actually, I'm going to use something different this time. I'm going to be using what's called a filter. So I'm just going to click here. I'm in cell H12. And I am just going to type in equals. Anytime that you're putting in a formula, you have to begin it with an equal sign. Then we're going to type in the word filter, type LTR. And then we're going to do an open parenthesis here. So the first thing it wants to know is what's the range of our data, the data range. So if you remember, it was A1 colon to E39, right? To E39. Then I'm going to put in a comma. Then they want to know what do we want to compare. So we are going to be comparing the data that's in E1 colon to E39 to see if it is greater than, whoops, I'll put a space, greater than space, the pedestrian count, which is F1 colon through F39. And you finish it out with a closed bracket. So what it says here is, I want you to filter, look through the data set that's in A1 through E39. Then I want you to compare the data that's in E1 to F1. If it's greater than F1, then I want you to display it here. So then it'll go down to E2 and compare it to F2, then E3 and compare it to F3, all the way down. So if I hit the Enter key, you can see this is going to show, and let me bring this out, the intersections that had a higher bike count than the pedestrian count. I'm going to pause it here for just 1 second. I'm not exactly sure what happened, you guys, because it's only displaying my bike count. It should also display the pedestrian count over here. So I checked my formula. It's exactly the same as my other one, so I'm not exactly sure what went wrong with mine, but hopefully yours is displaying the pedestrian count over here as well. So now that we have our filtered data here, what question could we answer with it? Well, which intersections have which intersections have more bikes than pedestrians? We can see that Hoover and McClintock is has the most bikes when compared to pedestrians. So what I want you guys to do is I want you to also create a subset from the data here, and then describe to me, well, write in a question that could be answered from this subset that you've created. So you can put it right here underneath where we've created this one, and then just put your question underneath the data set, or the subset that you come up with. So when you've got it all finished, save it to your Google Drive, and then submit it through your Canvas account. All right, and as always, ladies and gents, email me with any questions, comments, or concerns. All right, here we go.